Okay, I'm going to do an example that now has two things happening, part acceleration and part constant velocity. This is already typed up in the packet of papers that I gave you. Exactly like this, it's the only problem on the page, and it should be right after worksheet 4. So it tells us this cheetah can accelerate from rest to a speed of 27.8 meters per second in 5.2 seconds. The cheetah can maintain this speed for 9.7 seconds before it quickly runs out of energy and stops. What distance does this cheetah cover during the 14.9 seconds? So we'll start with our diagram. Again, not a good artist. Our cheetah is starting from rest. And then the cheetah accelerates and maintains this speed. So we want the same number of speed lines for the second and third parts. And I'm just going to break this apart into part 1 and part 2. If I list what I'm given, we know that the initial velocity in part 1 is rest, so they're starting from 0 meters per second. The final velocity for part 1 is 27.8 meters per second. The time for part 1 is 5.2 seconds. We also know that in part 2, the time for that is 9.7 seconds. And it is maintaining the speed from part 1, so the last speed in part 1, your V final 1, will be equal to V2, 27.8 meters per second. Because it's maintaining that speed, it's a constant velocity in the second part. So constant velocity means that the acceleration for part 2 would be 0 meters per second. And we are looking for the total distance traveled during the 14.9 seconds. So we're looking for delta x total. So starting with part 1, we're given final initial velocity and time. What we're looking for ultimately is delta x. Both equations that have delta x in them have acceleration. So we have delta x equals 1/2 at squared plus v initial t, or v final squared equals v initial squared plus 2a delta x. So in order to find delta x, I'm going to need acceleration. The only other equation we have left to find acceleration is v final equals v initial plus at. V initial was 0, so v final over time will give me acceleration. Final velocity, 27.8 meters per second divided by 5.2 seconds equals a. This turns out to be 5.34, run on decimal, meters per second squared for acceleration. This is not a number you want to round, so you want to store this in your calculator. Again, the store function is above the on button. You store it and then label it a number, because you want to make sure that you're using the whole unrounded number. Once you have acceleration, you have a choice whether you want to use this equation or this equation. Either one will get you the exact same answer. I'm going to use this one, but again, it doesn't matter which one you use. So delta x equals 1/2 times the unrounded acceleration, 5.34, keeps on going, meters per second squared, times 5.2 seconds. My initial velocity was 0, so that whole term goes away. Multiplying this out gives us 72.28 meters. And this is delta x for part 1. Again, not rounding because it's not the final thing I'm solving for. Now looking at part 2, this is where the cheetah is running at constant velocity. Constant velocity means that with this equation, delta x equals 1/2 a t squared plus v initial t. That whole middle term goes away. Constant velocity equation was delta x equals vt. I can get rid of the initial right here because your initial is the same as your final. So for part 2, delta x is equal to 27.8 meters per second times 9.7 seconds. Multiplying this out, we get 269.66 meters. For the total trip, delta x total equals delta x1 plus delta x2. So we get 72.28 meters plus 269.66 meters. This equals 341.94 meters. Problem has 3 sig figs, so rounding this to 3 sig figs gives us a delta x of approximately 342 meters. The main thing you had to look out for here was that you were recognizing 2 different types of motion, constant velocity and constant acceleration, and recognizing when to use which equation.